Hey folks, so now we're going to learn how to solve equations. So to do that, you should really understand about sacks of potatoes first, okay? So what I mean by that is this. Let's say you have one sack of potatoes equals another sack of potatoes. If you know that going in, then you can probably guess my next answer, or the answer to my next question. If you add 4 to both of them, will they still be equal? Definitely, right? If they start equal and you have the same number, you're still going to have equal sets bags of potatoes, just slightly bigger, right? And the same argument goes with if you subtract 4 instead, right? If you're subtracting the same number, they're still going to be equal, just a little bit smaller. And then people that are good with multiplying, like you can probably tell, oh, you know what? If you multiply by 2, you double both bags, you're going to have way bigger bags over here, but they'll still be equal because you multiplied by the same number. And the same thing is going to go for division also, okay? So if you get that, then you're going to get how to solve equations because I'm just going to use this method. Here's what I mean. Let's say I want you to solve an equation. I'll just make something up. Let's say you've got 3x plus 2.5 equals 10. Great. So you might be like, okay, I can solve that thing. I just need to figure out what number I can put in for x that will make the equation true. All right, well, go ahead, plug some numbers in. Try 3, get a calculator, see if you get 10. You didn't. Okay, well, try 4. Put this into the calculator, do it all, see if you get 10. No, nothing. Okay, so you could keep going again and again and again, right? And eventually, for this one, it's fairly easy. You would get it. It's a decimal number, but you would get it. But let me show you a method that works every time, and you don't always have to guess and check, okay? Here's what I'm seeing over here. With this sack of potatoes here, I can make it look a little easier if I take away 2.5. Because right now, you're adding 2.5, so I'm just going to get rid of that. But if I do that with this sack of potatoes, I darn well better do it over here also, okay? So can you tell what you get when you have this whole side and then you take away 2.5? Because these are like terms. They just equal out to 0. And then you have 3x plus 0. That's just 3x. Over here, this is just an easy one where you're going to get, what, 7.5? Okay. And then I have a 3 times x equals 7.5. How do you get rid of that times 3? Well, what's the opposite of times? Division. So if you take that side and you divide it by 3, and then you darn well better do that to this side, well, 3 divided by 3, that's just 1. And what's 1 times x? Well, what's 1 times 7? Isn't it 7? What's 1 times 10? Isn't it 10? So 1 times x is just going to give me x. And you can do this on a calculator, or if you're good with money or quarters or that kind of thing, you're going to get this answer. X equals 2.5. Shazam. And that's how you solve equations. Now, there are other wrinkles with negatives, and let me do one more for you, or with you, hopefully. Hopefully you're following along. So you can kind of see another thing. So let's do one. You know what? Let's do one where the x is on the other side. So let's go with 12 equals 4.2 minus 3.1x. Great, okay? Okay, well, I'm going to focus on this side because I need the x by itself, okay? And this is the side of the x is, so I'm going to be working with this sack of potatoes over on the right-hand side now, okay? Can you see, oh wait, I should say this. You got to get rid of these two numbers at some point. Which one do you do first? Don't worry about the multiplication number first. Like this guy here, save it for last. Trust me on that. get rid of the stuff that's getting added or subtracted. Knowing that, so I'm going to focus on this 4.2. Can you tell it's positive? So guess how you get rid of a positive 4.2? You subtract 4.2. And if you subtract 4.2 on this side, they'll still be equal, so let's do that. So 12 minus 4.2, this side is fairly easy. It's going to be 7.8, I think. Over here, what do we have? You know what? You don't usually need to do this, but for the first time here, let me write this all out in one line so you can see it. If you write this all out in one line, you end up with 4.2 minus 3.1x. Let me just make sure I'm still on screen there. Oops, there we go. 4.2 minus a 3.1x, and then minus a 4.2. Now, can you tell what the like terms are here? You got this negative 3.1x, and then what do you have after that? Can you tell it's nothing? Because 4.2 minus 4.2, that's just 0. So you can add plus 0 here if you want, but it's not going to change that negative 3.1x, right? So it turns out you end up over here with negative 3.1x. And you won't always have to write it out. Once you've done 4 or 5 of these, you'll just be able to look at this and be like, oh, these drop out, and I'm just left with this negative 3.1x. Sometimes you'll just forget the negative. Try to remember that. But now I've got essentially the same thing that I did on the last one, where I just have a number times x, and how do I get rid of that times a number? Divide the number. And if I divide by negative 3.1 over there, I darn well better do it over here. So, over here, negative 3.1 divided by itself is just 1. 1 times x is just x. And then this one I definitely need to do on my calculator. So, 7.8 divided by negative 3.1. Ooh, big long decimal. Negative 2.516. And you should know this. This is fine. It's usually typically polite to have the x go first. So if you don't mind, I'm just going to flip this around. I'm going to write x equals negative 2.516. Okay? And that is how you solve equations.